Cardinality is a fancy way to say size. The cardinality of a set A, written with two vertical bars around A, similar to the absolute value symbol that you see in algebra, the cardinality is the number of elements that are in A. So I literally just look in my set A, I count how many elements are there, and that is the cardinality. Let's do a couple examples. So here are three sets, and I'm going to see what I can figure out about the cardinality. So if I start with the set A here, containing 3, 19, minus 4, and 10, I'll notice, hey, the cardinality of A, I just need to count the number of elements. I count the number of elements. Here we go. 1, 2, 3, 4. The cardinality of A is equal to 4 in this first example. Okay, what about the next one? So I want to again know the cardinality of A, where this time the set A is equal to the set of all computer science minors. Okay, this time I don't personally know how many computer science minors there are, and so in this case we would have to say this is a case where to know the cardinality of this set, we would have to check with the registrar, and they could tell us how many computer science minors there are. That would be the cardinality of A. One more, this is a slightly more complicated example. What if A is the set of integers? The set of integers. So this is all positive and negative integers and 0. How many elements are in this set? Well, there's an infinite number of elements in this set. So in one sense, it's correct that the cardinality of A is infinity. This is a little bit imprecise, as you might learn if you take advanced math classes. The specific kind of infinity is called countable infinity. So this set has the cardinality of countable infinity. There are also such things as uncountable infinities, which are larger. So there's also one kind of special set that we haven't talked about yet. There's this special set called the empty set. It's called the empty set. Sometimes we also write it as curly braces with nothing in them. So this empty set. How many elements are in the empty set? Well, if I look at the empty set, it has no elements in it, which is another way of saying that it has 0 elements in it. So the empty set is a special set that has no elements. It has cardinality equal to 0. So set cardinality is a simple answer to the question of how big a set is. And when we're asking that question, notice that we're not paying any attention at all to the size of the numbers that are in the set or anything about what's in the set. All we're doing is looking at how many things there are in the set in order to determine the cardinality. Sometimes when we're looking at sets, there's some kind of set that is clear from context that contains everything that we would possibly care about. And we call this the universal set. Often we write this universal set as U. We regard U as the universe of things that we're interested in, at least in the context of whatever problem we're working on. We're not expecting to be interested in any other kinds of elements other than the ones contained in the universal set. So, for example, maybe I'm studying something about the numbers, just numbers in general, and I'm interested in the set of integers, but I'm kind of also looking at the set of all possible real numbers. So maybe the set of integers is the specific set that I'm interested in, but then the set of all possibilities, The universe that I care about is the set of all real numbers. Or another example, maybe my set A is the set of all computer science students. In this context, maybe I'm comparing or contrasting the set of all computer science students to the set of all students who are at the college at all. So that might be the universe of comparison that I'm interested in. When we have a universe of comparison, we can define one more important logical operator, and that is the complement operator. So, given a single set A as well as the universal set U, the complement of A, which we write as A with a little bar on it, is the set of elements of the universe which are not elements of A. It's the set of elements of the universe which are not elements of A. You'll notice that this sounds a little bit like set difference, and indeed it's exactly like set difference. Another way to write this is that the complement of A is equal to the universe minus set difference, the set A. So when I have a universe, I'm able to talk about the complements of sets as well, everything that's not in that set but is in the broader universe. If I don't have a universe to talk about, then the concept of a complement is not well defined. So let's look at this as a Venn diagram. Here's a set that I'll think of as A. And then here, in addition, and now here is another set that I'll draw around A. Here we are. So this set is A. And this exterior set, that's the universe. That's the set of all possible things I could possibly care about. And A is in there. Now, the complement of A, in this case, if I want to form A complement, what I need to do is I need to look at everything that's in the universe that's not in A. And so that means everything that is in this universal set excluding the contents of A. So if I want to write complements using Venn diagrams, what I do is I look for everything that is not in the set A and I shade it in. There's a nice math formula that describes the cardinality of the complement of a set. So suppose that I have a similar Venn diagram to the one that I had before. I have a set A sitting inside a universal set U, and I want to know, hey, what's the size of the complement of A? What's the size of the complement of A? Well, to find the size of the complement of A, one way to go about it is I'm going to say, hey, let's look at the entire universe U and start with whatever size that is. Whatever size universe U is, that's the size of the entire world, the entire space of things that I could possibly care about. And inside that space, there are some elements that belong to A. How many? Well, by definition, the cardinality of A. So to find the cardinality of A complement, it's enough for me to start with the entire universe, figure out the size of that, and then subtract off everything that is inside A. Now, importantly, this only works if the universe is finite, if it has a cardinality that is a sort of finite number. If it's not, the situation gets a little more complicated. But for this class, we're mostly going to focus on finite universes, and so when I want to calculate the size of a complement, I can do it using this formula.